Okay, I'm looking at number 8, and I know they want me to analyze this with the transition points. I'm looking at the graph, I'm looking at the function, and I certainly see concavity in the problem, but I don't see any extrema, all right? So what I want to do is I want to go through the derivatives first, and it's going to be somewhat difficult to do that. As I do that, though, I want to rewrite this guy. And I'm going to rewrite it as, x times x minus 1. And then I'm going to get 3x minus 3 plus 3x. And this guy's over here is going to be 6x minus 3 over x minus 1. Now, granted, I realize a lot of times when you're studying, you may wonder what direction I need to go in. For credit, I'm going to say we're not looking for basic algebra skills. We are looking for basic algebra skills, but more importantly, we're looking, can you get the derivative? All right, let's write this down now. So I'm going to say this is f of x. And let's put f prime down, which is y prime. Square the bottom. That's not so bad. Whoops, made a mistake already, didn't I? I said square the bottom, right? I was thinking about multiplying it out, by the way, but I don't want to do that yet. And then what I'm going to do on the, I bring the bottom to the top, times the derivative of the top, which is 6, minus the top, times the derivative of the bottom. And I want to point out the bottom is really just x squared minus x. So you can get 2x minus 1. All right, I'm going to keep working on it. I want to massage it, make it nice and neat. Before I go forward, I should emphasize that to me, this thing is all real numbers, but x cannot be 0, and x can't be 1. And I clearly see it in the picture. So let's just take a look at this over here, and I have to multiply it out, and on top I get 6x squared minus 6x. That's this business right over here. I'm going to do this now, and that's going to be what? Let's see, 6x times 2x is 12x, so minus 12x squared. And then you get, let's see, minus 6 is minus 12, so plus 12x. And minus 3 times minus 1 is plus 3, so it's minus 3. I'm still not done yet, by the way. X squared, x minus 1 squared. And on top, what do you get? You get minus 6x squared plus 6x minus 3. I'm going to factor out a minus 3. And what do you get? 2x squared minus 2x plus 1. Let me see if I did that right. Minus 6x squared plus 6x minus 3. Yeah, looks pretty good. And this is the first derivative. I want to go back over here and look at it and see if we did that right. And this is what you want to do when you're studying. Let's see, 2x squared minus 2x plus 1. Yeah, I did okay. All right. Now, what do I know about this over here? I do want to look at it. Are there any critical numbers? Well, you might say 0 and 1, but that's not in a domain, so I can't use that. I do want to look at the top, and I was wondering if the top is ever 0. Let me write this down. I'll probably end up erasing it. And for it to be 0, I'd have to say, is this ever equal to 0? Let's write the x equals. Let's see, twice the a, that's 4. The opposite of b, which is 2, plus or minus. And let's see, you get 4 minus 4 times 2 times 1. It's complex, right? So as expected, I'm not getting any extrema in the problem. Let me erase this over here. Now, of course, I'm getting concavity, and I'm seeing a point of inflection in the problem. But before I do that, I want to point out I'm definitely seeing, what appears to be concave down here, what appears to be concave up here. Over here, I'm seeing something, you know, concave up and then concave down over here, all right? I got troubles though, and the troubles is the second derivative, and I understand that's difficult. So I want to write it down, and as I go through it, I have a, you know, something to aim for. And I got to square the bottom, so that's x4, x minus 1 squared. Bring the bottom to the top. Times the derivative of the top. Let me write the top down for you. And it's going to be minus 3. And then I'm going to get 4x minus 2. Minus the top. Well, minus and minus is plus, so plus 3. And then what do you get there? 2x squared minus 2x plus 1. All right? And now I gotta do the derivative of the bottom. And as I do that, I might do something pretty strange here. But the bottom is really, you know, x minus 1, this whole thing squared. Right, so I think I can write that down. So it's going to be 2 x minus 1 to the first power, and then derivative of the inside. And the inside is going to be x squared minus x. So the inside of this thing is x squared minus x. So that'll be 2x minus 1. All right? Let me get my eraser out. I'm going to erase this business over here. And I'm looking at this thing, and it looks awful. But I'm going to go step by step through it. All along the line there. x4, x minus 1 squared. I'm sorry, that's 4. Sorry about that. Well, I'm going to look for things that I can, you know, factor. And some of the things I'm looking at, I want to point out, I'm looking at this over here. And I really see this as 2 times 2x minus 1. So I'm seeing 6 common to both terms. And I'm going to pull that out. Right, I'm looking for things that are common to both terms. I'm definitely seeing an x minus 1 and an x. Right, I'm seeing an x minus 1, and I'm seeing the number 6. Let me cross this out over here, because I wrote down 2 times 2x minus 1. I also see a 2x minus 1. And I think that's about all I see there. And it's tough. There's no doubt about it. So let me just look at the first term. Right, I'm going to rewrite that first term. I'm going to rewrite this guy over here. Let me write this down for you. I see x squared. I see x minus 1 squared. I see that, you know, the minus 2 and minus 3 is minus 6. And 2x minus 1. Well, I pulled the 2x minus 1 out. I pulled one factor of x minus 1 out. I pulled the 6 out, so I'll have a minus 1 over here. And I pulled one of the x's out. Right? So what are you left off with? You left off with x. You left off with a factor of x minus 1. And you got a factor of minus 1, too. Well, I'm going to erase this up here. And I want to be careful before I go forward, because it looks like a really nightmarish problem for me. I want to see, I definitely got the x squared. I got the x minus 1 squared. I got the minus 6. And I got the 2x minus 1. Let's go to the next term. Plus sign. And I'm looking at this over here. I see the 6x. Let me use my highlighter for that. I pulled out the x minus 1, and I pulled out the 2x minus 1. Well, I'm left off with something pretty simple. I'm left off with 2x squared minus 2x plus 1. All right, I got to keep going. and yes, it's a difficult problem. I'm going to reduce it. X cubed. I'm reducing this and this. I'm going to reduce this and this. And that's going to be x minus 1 to the third power. And then what do you get over there? Let's see what's left. You're left with 6, and you're left with 2x minus 1. I got to do what's inside this symbol over here, which doesn't look that bad to do, by the way. So it looks like, minus x squared. And then you're going to get plus x. Let me stop for a moment and see if I got that for the first term. X squared minus x squared plus x. Good. Plus 2x squared minus 2x plus 1. Let's write that down. You're going to get x squared plus x plus 1. All right, so I got some troubles now, and the troubles are going to be, I might have forgot why I've done that. I've done that for concavity. So I know there's one point of inflection at this point, and I'll tell you why I know that. I'm looking at this, and it occurs at a half. Let's go back to the picture, and I'm going to say this is the point of inflection over here. So it's 1/2, f of 1/2. All right? But I'm not seeing any other points of inflection, so I'm wondering about, this quadratic over here. And that quadratic over there, if I look at it, I'm going to say x squared plus x plus 1, does that ever equal 0? Well, let's go through that. X equals, let's see, 2. We're going to get minus 1 plus or minus the b squared, 1 minus 4. Oh, it's complex. So only one point of inflection. All right, no extreme, but one point of inflection. Before I go forward, though, I want to claim, though, I'm looking at the answer key. I definitely see this. I definitely see the 6. But what appears is, it appears that this has been multiplied out. I want to check it. I want to check if this and what I've written down are the same thing. Let's go through that. So I'm going to check out 2x minus 1 times x squared plus x plus 1. And I'm hoping this is what the key says it is, which is 2x cubed minus 3x squared plus 3x minus 1. Well, let's multiply it out. You get 2x cubed plus 2x squared plus 2x minus x squared I think I might have made a mistake somewhere. 2x minus 1. Let's take a look at that. 2x squared I see it now. I see my error. Let me erase this over here. Let me make my eraser a little bit smaller. And I did make a mistake, and I want to just correct it. And I want to point out, when I was looking at this thing over here, I said minus x squared and 2x squared was 1x squared. But then I said x minus 2x was plus x. That's not true. It's minus x. So I got that part covered, plus 1. So I had to revise my work, by the way. So let's go back over here. It's a tough problem, and I'm going to check it again. So I'm going to check 2x minus 1, x squared, minus x plus 1, and I'm checking is it the same thing in the answer key, which is 2x cubed minus 3x squared plus 3x minus 1. Let's go through it. You do get 2x cubed minus 2x squared plus 2x minus x squared plus x, and then minus 1. If you combine that all together, you do get 2x cubed minus 3x squared plus 3x minus 1. It does work out. I did make one small correction, by the way. So again, it works out pretty nicely that we're able to get what the key is reflecting as the correct answer. Again, there's only one point here, a transition point, and that's the point of inflection, and we were able to verify that with our work. It's a tough problem, by the way. Thank you.